So now that we've talked a bit about the distinction between a platform thread and a virtual thread, let's take a look at a case study that will demonstrate how to program both of them, and it'll also give a feeling for why you might choose one versus the other. And so we're going to take a look at this little example, which you can find in the ex1 project in my Loom directory in my Live Lessons GitHub repository. And that's going to show the different ways of creating platform threads and virtual threads. So we're now in the IntelliJ project for case study ex1, which is in my Loom folder, which has a bunch of different examples. And the first thing I want to show you is how do you actually build something that uses these new Java virtual thread and platform thread capabilities. So what you need to do here is you need to modify the build.gradle file to tell the compiler, please enable preview features. So these virtual thread mechanisms and so on, and platform thread mechanisms are what are called preview features in Java 19. They're in Java 19, but you have to enable preview mode. And then the other thing you need to do is you need to make sure that in your configurations pane that you enable preview as well in the JVM options, which you can add simply by going here and clicking on Add VM options. So you need to enable the preview. And we'll see some more examples of this as we get further along. You can also see that we have some command line arguments passed into this program. We're going to turn on debugging, and we're going to print some diagnostics every 100 threads we create. So armed with that, let's go over and take a look at the source code. So here is case study ex1. This shows how to create, start, and use virtual and platform thread objects in Project Loom, which is actually now, I should replace this and say, in Java 19, which actually now contains an implementation of lightweight user threads or virtual threads. And you need to install Java 19 with Gradle 7.6 configured, otherwise this doesn't work. So we're going to have a couple of fields. We're going to have something that's going to keep track of some randomly generated integers, which we're going to check for primality with gobs and gobs of threads. We're going to keep track of the iteration count as an atomic integer, starting at 1, or at 0 rather. And then down here we come in and we parse arguments so we can set the number of threads we want, whether we want to run platform threads or virtual threads. The default, as you'll see, is to use virtual threads. Here's the options class, and you can see here that we're going to have virtual threads set to true, and we're going to start out with creating 2,000 virtual threads, which is actually just a pittance. It's hardly anything. And then we're going to go ahead and print out a diagnostic. We're going to generate a whole large bunch of random numbers up to a very large range. And then we're going to run the main entry point method into this test, which says start threads, and we're going to designate whether we want virtual threads or platform threads to be created. And here's what the main program does. It iterates from 1 to the number of threads we've asked it to create, which will be defaulting to 2,000. And we print out a little diagnostic. Every so many iterations, we print out a diagnostic, so we don't just blast out diagnostics galore. So this is defaulting to every, I think it's every 100 iterations, it'll print out a diagnostic. And then we go ahead and do something fun. We make a thread, and depending on whether we have the virtual option enabled or not, we're either going to make a virtual thread or a non-virtual thread. And we're going to make a runnable that will go ahead and determine whether the ith random integer is prime or not. So we always like to fall back on this example because it burns a lot of CPU time. So it helps to demonstrate long-running things that can take advantage of concurrent programming with multiprocessor or multi-core processor. So let's go ahead and take a look at make runnable and see what that does. So make runnable returns a runnable, and what this runnable is going to do is it's going to check to see if a number is prime, and then depending on whether we've got diagnostics enabled, we'll print out the results, and we increment this iteration count so we know how far we've gone so far. And that iteration count, as you'll see, will run concurrently, which is why we use an atomic integer. So let's take a look at make thread. This is where it gets really interesting, and this is really what focuses in on the platform versus virtual thread features in Java. So you can see here, if we're creating a virtual thread, we say thread.ofVirtual unstarted, and we give it that runnable to run. Otherwise, if it's not virtual, we say thread.ofPlatform unstarted and give it a runnable to run. So either way, we're giving back a thread, which is either a thread object, which is either a virtual thread or a platform thread based on the parameter we passed in. And then we go ahead and create a list of all these threads. So we have a list of thread objects. They all started, they were all created, not started. They were all created in the unstarted state. So now we're going to go ahead and use the for each method on the list and say start all the threads. So all those threads are going to start. If they're platform threads, I'll allocate a big chunk of memory, virtual memory for each thread. If they're virtual threads, they will occupy space that's very much smaller using a fork join task under the hood. And then all those threads start to run, cranking away, computing the prime numbers, their given prime number that they were given. And then this thread uses barrier synchronizer to wait for all the threads to finish. That's the join method on thread, which now works for either virtual threads or platform threads. So that's basically the program. Let's go ahead and run it. And you'll see that we're going to start out by creating a bunch of virtual threads. And it'll take a second to start up. And you can see it runs very quickly. And it computes. It tells us some things. It gives us some diagnostics as threads are started. We're going to create 2,000 virtual threads. Every 100 threads start, it says what it's doing. And every so often, we print out what the smallest factor is, whether it's prime or not. So that's essentially that. And you can see it took 8 seconds or so to run. So now let's go back over here. And let's change this to, I think it's -t. And we're going to say, I think we say false, but let me double check that just to make sure. So we have an option over here that lets us toggle back and forth between, P and V. That's a better option. So by default, it's V, and let's change it to -t P. So now we're going to go ahead and create platform threads, and we'll run the test again. And what you'll see is we get the same results. It runs. And so far, it looks pretty much the same. So platform threads and virtual threads behave the same. But now let's see, we come along here, and we want to really start putting this thing through its paces. So let's go back over here, and we're going to give a -n option here. So before, we were only making 2,000 threads. Now let's go ahead and make 2 million threads. And let's make those virtual threads. So now we're going to go ahead and make 2 million virtual threads. And you'll see that it'll, again, it's printing out every 100 threads. It indicates what it's doing. And it went ahead and cranked away, and it ran pretty darn fast. So we had 2 million threads running, doing all those tests. But and you can see it ran very quickly. Let's come back here and make this P for platform thread rather than V, which is the virtual threads. And you can see it's taking a lot longer to run. And that's because it's got to coordinate and schedule all those platform threads that are running. And it's just going to take a lot longer because it's got 2 million of them. Now, that's pretty darn impressive if you think about the fact that we've got 2 million platform threads running. But that's largely because I have a computer with 10 cores and 64 gigabytes of memory. So it's got a lot of resources, but you can see it's way slower than the other version. And now just for kicks, let's go over here and let's only print this out every 100,000 times. And let's make 20 million threads. So now we're going to see if we can make 20 million virtual threads. And you can see that those threads are starting and they're cranking away, doing their thing, and it's taking not very long to do the computations for 20 million threads. And let's see if that will finish. There we go. It's done. It took 14 seconds. Now let's go ahead and make we'll try to make 20 million platform threads and see what happens. And depending on how things go, you can see it's still doing its best to create an incredibly large number of threads. Let's see how long it takes these things to run, though. And I may not let this thing run forever because it's going to take a long time. Now, again, we're doing a pretty darn good job on my MacBook Pro with lots of memory and lots of cores to create a ridiculously large number of threads. But I think what you're going to see now is now that we've created 20 million threads, it's going to take a really long time to get the results. In fact, it may very well just hang. I've had that experience a couple times. I had to shut down my IDE because it just got overwhelmed with the number of threads. So the key point here is that I'm not going to waste our time waiting for this thing to finish because it may never finish, because 20 million platform threads is a ridiculously large number. But there you go. Now I finally got to the next chunk. But the key point here is that virtual threads allow us to make ridiculously large numbers of threads that can do pretty much the same thing that the same number of platform threads could do. It just does them in a much lighter weight fashion.